What is the principle of superposition for structural engineering? Imagine a scenario where multiple forces act on a structure at the same time. Understanding how these forces influence the structure individually and collectively is essential for safe and efficient design. The principle of superposition provides a systematic way to analyze such complex situations by breaking them down into simpler parts. In structural engineering, this principle states that the response of a linear system to multiple loads can be determined by summing the responses caused by each load acting alone. This means if a structure is subjected to several forces, the total deformation or internal forces at any point can be calculated by adding the effects of each first considered separately. For example, if a beam experiences both a vertical load and a horizontal load, the total bending moment at a specific point can be found by adding the bending moments caused by each load independently. This principle relies on the assumption that the material and the structure behave linearly. Linear behavior implies that the relationship between applied forces and resulting deformations or stresses is proportional and reversible. When this condition holds, superposition is valid. If the material exhibits nonlinear behavior, such as plastic deformation or large displacements, the principle no longer applies directly. Practically, superposition simplifies complex structural analysis. Engineers can analyze each load case separately using methods like finite element analysis or classical beam theory, then combine the results to understand the overall response. This approach saves time and reduces computational complexity, especially when dealing with structures subjected to multiple simultaneous loads like dead loads, live loads, wind, and seismic forces. It is important to note that superposition applies only to linear elastic systems. For structures experiencing nonlinear effects, alternative analysis methods are necessary. Nonetheless, the principle remains a fundamental concept in structural engineering, enabling engineers to predict how structures will behave under various loading conditions accurately and efficiently.